Well, people are going to inevitably jump on throughout this, I'm sure. So if you guys just want to maybe introduce yourselves and start, we might as well get rolling, I guess, right?
All right, that's great, Steve. Thanks for setting this up, and I appreciate people being willing to listen to what we've got to say today. It's not necessarily a sales pitch, although hopefully we're going to come across very favorably. But this is a great opportunity for us to get inputs from the pros from Dover, experts in the field of HAZMAT. So a huge opportunity for us. I'm Ed Hoffman, as it says so on the screen. That's not a lie. Our company is Venti. We are a startup, but we've been around for about 4 years. And our goal is to come up with real-time situational awareness for people in the emergency response community. My personal background is Air Force. I guess I should say U.S. Air Force, a lot of flying, and then working with an industry in the Air Force with sensor information. We call it sensor to shooter, trying to get real-time information to people that needed real-time information to handle a problem. We're trying to take a lot of that same stuff and approach and concept, and instead of using it to start fires and things like that, try to put them out. Phil, I'll let you talk in a second, but I do have to warn you, he worked for the lesser service in the U.S. military. People who fly airplanes part-time, but it's not really a mission for him. Go ahead, Phil.
Absolutely. Phil Tinsley, been working with this young man for over 20 years. Like you said, in the 90s, we did, when we were still putting on flight suits together, not together, but anyway, we were both putting on flight suits and got into what was called RTIC, RTOC. And then I was also involved with what's called TENCAP, Tactical Exploitation and National Capabilities, where we're taking the let's just call it NRO type information and downgrading it so that the operators can get that data in real time. And so that's been a huge, that was a great job to have. And then retired, went on to Lockheed Martin and worked lots of space programs, again, trying to get the data down to a usable party. Been working on Venti and what we still call Intellipod. If you go to our website, it says Firefront. I'm going to use Firefront later on a program that we just got approved for. I'm going to let Ed talk, but other than that, carrier aviation, 500 carrier landings. So I know what it means to have an understanding of your threat, obviously. So looking forward to working with all of you, and let Ed have the floor now.
All right, gentlemen, what we're going to be talking about today is a system that we designed of very lightweight, small remote sensors that can be deployed on scene immediately to start feeding back information, whoever the incident commander is or whoever the head mucky-muck is that's trying to control the operation. What I'd like to start with is a video, and if you went to our website, you'd see it. So if you've done that, I apologize for the repeat. It's about 3 minutes long. It's a cartoon, but it does a pretty good job describing the concept of what we're trying to do. So let me see if I can execute this correctly.
When you arrive on scene, there is never a moment to lose when you need to size up the dangers of the situation. Every fire incident has its own unique unknowns that can put first responders and the surrounding communities at grave risk. In the past, standard protocol was to send in personnel to assess the situation, despite the very real risks of flashover, backdraft, or even explosion. Finally, PPE and situational awareness have evolved. Introducing Firefront, based on the exclusive Intellipod system by Venti. The low-cost, disposable Intellipods contain lightweight RF-capable microsensors that provide real-time metrics on condition, location, temperature, and velocity of the fire, and the presence of vibration. Future audio, video, and HAZMAT capabilities are in development. Whether the Intellipods are thrown in windows on lower floors, launched from an air cannon, or dropped from a hovering UAV, the Intellipods are instantly sending crucial data back to the incident commander on site. In conjunction with the Firefront UAV, several streams of data combine to send real-time information right where first responders need it most. Another capability addition may include embedding the same 1.1 ounce sensor directly into the first responder's protective gear or equipment, thus providing the IC with an integrated picture of each individual's location, health status, and deployed Intellipods. The heart of the Firefront system is our GIS platform, which captures and analyzes all types of spatial and geographical data. This mission-critical information is received from inputs from the Intellipod sensors and UAV and allows ground teams to zoom in to areas of interest. The incident commander can even choose to get data from individual Intellipods or all of them at the same time. To maintain situational awareness, when one Intellipod is destroyed, another can be deployed to replace it. Geolocation makes it possible for responders to be notified instantly of nearby schools, child care centers, medical facilities, and other citizen populations should emergency evacuations become necessary. And if an Intellipod with HAZMAT capability detects toxic fumes or chemical threats, responders can be provided with a warning tone via command net radio or personal audio warning device, giving them a tactical advantage that may save their lives. And even when the situation has been contained, Firefront keeps monitoring the scene. If temperatures begin to spike, or when HAZMAT capability is added, ongoing threats like gassing and persistent HAZMAT presence can be dealt with quickly. Firefront offers an unprecedented level of safety for communities, first responders, and their equipment. The Firefront system gives your team the tactical advantage that can save lives. Make the call today.
You don't have to call today. And that's probably about 80% accurate now from when we put that together. But the concept is still there. And what we'll do now, now it's time for the PowerPoint presentation. I know everybody looks forward to these things. This isn't 50 slides long, so that ought to help. Phil, give me a shout if these things don't advance like we had that with the other problem.
Roger.
Anyway, so what we originally decided or just tried to do is look at a very specific issue of firefighters showing up and not knowing exactly what they had other than maybe a bad 911 call, and get that information without having to set up stuff. You don't need to burn in time. You turn it on and deploy it. When we looked at HAZMAT, and this is kind of a test for us to see if
Still not advancing, Ed.
I'm saying again?
Did you advance?
I did.
Yeah, I'm still on the cover slide.
I don't think you're in presenter mode there. I can see your whole PowerPoint program. Like, I don't think it's actually presenting.
Looks like he selected it.
No, it's showing that it, on my system, it's showing that it is, because I've got 3 screens.
Interesting.
Is that advancing now?
No.
Can you advance manually
No.
on yours, from your end?
Stand by. No.
Okay, I would say offhand that there's a disconnect problem here. All
Did
right,
you
let me go
send it
to,
to Steve real quick?
say again?
Yeah. I just see your PowerPoint program. Like, it never went into presenter view, it seems like.
Yeah, there's a glitch here somewhere. Well, let me do this. You can still follow along.
That advanced.
Say again?
You're on slide 2 now.
That's interesting. Oh, well, I will have to call in to Geek and say, why is this happening? Now, am I in a presenter mode or just the overall?
No, just
Overall mode.
slide mode.
Okay. Well, as long as people can see the slides.
Yeah, we can.
This problem slide, we're not trying to dictate what your problems are. We're just kind of, again, like kind of a test for us. Do we understand the kind of problems that you're dealing with when you go to respond as a HAZMAT crew someplace? Because if this is, then what we're trying to do is come up with a way of helping that crew respond faster to what the problem is. And the way we're going to try to do that, because there's a number of things you can do, obviously, but if we can get fast information, real time, and we like using the term real time because it's what it is, real time information that will give situational awareness, not just data, but take a look at, I say a perimeter specific areas where you can put very small, lightweight sensors and, oh, by the way, low cost, that can sit and monitor and show you what's going on, whether it's potential for increasing volatile gas, whether the atmospheric conditions are changing rapidly that can drive how a toxic chemical is going to interact. Can we do that and really help expedite the recovery from the hazmat situation. Oh, and protect people. Currently, this is the solution that we have. This is our prototype, but we've been able to test this in a number of pretty challenging areas, all in test facilities. We haven't found anybody to let us burn New Bern down yet to try to get a full reading on how this works. But these are the kinds of things that we can do with this system. You can see it's not terribly large. The Pelican case you see in the bottom left-hand picture, that's our control station or control system. That has all our radios, communication gear in it. It's also got our recharging scheme for keeping the pods charged up constantly. And then you can see the pods in the sort of top right-hand picture. And they fit in your hand about the size of a hard ball. Right now they weigh 4.2 ounces. And that big silver button you see in the middle, that's what actually turns the pods on and off. And you can actually activate that if you're wearing a glove. They are designed to be disposable. Should probably didn't use that term. Let's say consumable, so that they would be at a price point that a responding crew shouldn't have to worry about having to write up major reports because they burned up a $10,000 sensor. These things down in hundreds of dollars, and as we get into full range production, we can see that price coming down even further. This is the big scheme of why, one of the reasons why we think this is kind of a unique approach to the problem, is that you can use it just about anywhere you can imagine. We've had them tested, and we'll go into this in more detail. I'll let Phil talk to it, in wildfire testing, which isn't necessarily a hazmat environment, but it certainly would represent a remote environment. Structures, and we're even in, say, discussion, building a relationship with FSD to instrument at least portions of their training facility, so that they could monitor, they would like to see if they can monitor what the trainees are being actually exposed to. But you'll see in the yellow circle, that's what we currently measure in each pod. That's not one sensor per pod. Each pod right now measures all those things. And it pushes through to any personal computing device that you want to attach it to. And then, of course, what the big deal is obviously the information. Can you get it to the incident commander? And if it has to go sideways through the IoT or vertical to a PSAP, then be able to do that in real time, same time the incident commander is looking at it. Right now, today, we store that data from all our tests, and we'll show you some of the results of that. So that we encrypt it, we put it up in the cloud, and then afterwards it's got forensic application, or over a period of time, depending upon what kind of events it measures, you can also do all sorts of clever data analytics to determine trends and maybe even put that into some predictive modeling. I think I pretty much covered all of this on the last slide. One of the things that we think is particularly useful, and it's a lot of the feedback that we've been getting from all the people that in the real business that we talk to, is that we can really throw these things downrange. You don't have to carry them in. You can carry them in. In fact, you can even strap it to scuba gear to monitor each individual's exposure and movement. But one of the things we wanted to try to do was get this small enough, lightweight enough that if you wanted to use a drone, and we've got some test videos that we can show, we can do a couple of clever things, at least, well, we think they're clever, with the pods from a UAV or drone deployment. One is we've designed a universal carriage system that you can mount to just about any drone and drop these things wherever you wanted to. And they work when they hit the ground. We can also do a retractable tethered rig, and we've tested this as well, so that you could take one of our pods, put it on a tether, and then we call it dipping, dip it into whatever the environment is you want to measure, and then pull it back up when you're done and fly around and continually do that if you're trying to map out the spread of something. It does a couple of neat things over just mounting it to a drone. One is you can get it far enough below the drone that you're not in all the rotor turbulence. The wind field under quadricopter is incredibly chaotic. So now you can get it down where you can actually get some pure samplings. The other thing is you could just put a long cord between a pod and the drone. Now you're trying to fly a drone dragging 50 to 100 feet of cable underneath, and that's really hard to do. This is going to be used with some of the wildfire testing that we're doing down in Florida. We're actually going to build a tether rig for a large-scale drone. This is some of the testing that we've done with it. Pictures, let me just take you quickly around the photos so you know what they are. Starting on the far left and then going clockwise, we're part of a what's called CERTIP. It's a DoD program for environmental development and research, subcontract in the University of North Carolina. They're trying to model the dynamics around the wildfire so they can use it in fluid dynamic modeling. So they're using our sensors to try to get information, environmental data, prior to a fire line and then after it passes. So they can try to use that for modeling how the fire is moving. But the neat thing for us was we had to deploy this remotely. And you can see on the left picture, they've got a tower that has a lot of control stuff on it. If you look really close, you can see our control box about 10 feet off the ground. And then we had to deploy the pods in a line that they wanted to measure the test with. And we had to leave it there for over 8 hours. In fact, it was just about 10 hours. And the system sat there operating, recording data for 10 hours. And that's the first time we were able to test that in the field doing it. The second picture, you've got the simulated car fire, which I know is not necessarily a hazmat thing. But if you look real close, you can see a small little P3 drone hovering over the fire, and you can see a red sensor that we're dropping down into the fire on the tether, where we were able to bring it down, get the readings, in this case, temperature readings, and bring it back up. The next picture over is a pod sitting by your standard training fire pit. What we were trying to do here was see if we could get enough fidelity in our measurements and at the right interval where we could see if we could detect the increase in the VOCs prior to the fire igniting in a pit. And we could do that. I know it's a very controlled environment, but one of our goals with this is to be able to monitor areas where there could be gas leaks. And can you detect the gas leak before it actually would ignite? Picture next one over, young firefighter, head of the HAZMAT team now at St. John's Fire Department in St. Augustine. Florida is shooting the air cannon. We can get about, about 200 yards off 85 PSI. And the pod records from the time you turn it on, drop it in a cannon through the whole arc and when it hits the ground. So that's at least a 10G acceleration that it's dealing with. The next picture is just one of our pods suspended on a cable that was simulating having a pod suspended above the ground. And then the next one's down is just some of where they were doing some test fire lines and positioning our pods so that the fire would sweep over it to get the right readings. This is normally where Phil says, Ed, shut up, stop talking, take a breath. And so I'm going to let him pick up the discussion. And you just tell me, Phil, when you want me to move the slide.
Okay, this is the slide for the MIFRE demonstration. We spent an entire day with a number of students there. We showed that they could actually wear the pods and you could actually demonstrate the extremes that they were experiencing within the test building. We were able to get the data out of a metal test building, which I was amazed at. And it went so well, like you saw the fire pits, and they have a test house that they reconstruct for a forensic analysis class They asked us to instrument it. So the upper left photograph is how we did the instrumentation. And if you look at the graph, you can see the actual spike of the temperature. And they said they had no idea the actual extremes that that house was going through. And I believe that one goes up to 1200 degrees. I want to impress upon everybody just how rugged these little things are. This is the one we pulled out of that car. And once the firefighter gave this to me, it was very hot, obviously, but it was still reporting data. And I've shot these things well over 200 yards. They actually report during the acceleration so we can get the G readings, as well as survive the entire flight. Most firefighters will immediately come up with another idea. I was working with the St. John's group, and they asked me if it was waterproof, and I said that one was. So he immediately wants to throw it into a hazardous spill, and then immediately get position, report speed of the current, so you can now lead turn the spill, or if there was a drowning victim, you might be able to understand a better location of where the victim might have shown up, which is something Ed and I have experienced with the military. As soon as a kid is given a new tool, he comes back with ideas of how to utilize it that never was considered. And so I'm expecting that to happen with our Intellipod. Next. This is a great screen capture of the temperatures down below okay, here we go. You can see on the left the GUI, the graphic user interface of our GPS reports, so you will know exactly where they are. I've taken a number of pods out here in Colorado. I've strewn them around the Peterson Air Force Base, and you can actually see reports of exactly where the pods are located. We think that might be a tremendous tool set for you guys if you were to set the perimeter around an event. And now you know exactly where those are, and then you're going to be receiving the readings of the VOC sensor, which is volatile organic compounds. You guys know that, as well as temperature, pressure, humidity. I think there's going to be a case for understanding what happens to atmospheric pressure as the event proceeds. We saw and humidity. We in the last run at Tall Timbers, we saw a spike in humidity before it was zero as the temperature increased. So I think there's some interesting analysis to be done there. And you can actually see the spike in the temperatures there. And down below, you'll see the other readings in parts per million and for CO2, VOC, humidity, and pressure. Next. This is an example of what we can pull back once we, for post-event analysis. The blue graphs were made in the burn building at Mifree. You can see where the fire is extinguished, then they close the door after extinguishing, and you start to get an increase in both CO2 as well as temperature. Down the third graph is our vibration sensor. I believe there's going to be a use for that as far as a warn sensor, where once you're walking around with it, we're going to get those vibrations. If, for example, they go to zero, we might have you down, and we'll know the position of your of the men you have that are down. On the right, you see the temperature extremes that we experience at Tall Timbers. Still need to do more analysis on that, and we're going to get invited back, and we're going to be able to use a drone for tethering capabilities as well as analysis of how the fire progresses. Edward, you can have the floor back.
Anyway, we think this does something different now that is not currently available. We don't say that we exactly designed this for hazmat teams. We think it has great application there, and that's one of the important things, most important thing to us today is we're in a prototype status. We know things will change. There are a lot of things that we want to do as we go forward. So we're trying to get a good handle on what those things might be. So we got some direction that we can develop this thing in. But one of the things that Mifree thought was really important was to be able to tell the advent of a potential flash hole. And that's what they really wanted to see when we did that burn structure test. Could we see the temperature rate rise and report it in a timely enough fashion so that an incident commander could pull people out if it started to develop. The pods right now report once every 4 seconds, but that's software programmable. It'll actually report as fast as 50 hertz, which is great for engineering stuff, but I'm not sure there's much value in an operational sense. Or we could drag those things out. If right now, what we found testing outside at reporting every 4 seconds, the batteries will last 10 to 12 hours reporting data. If you slow that down, then obviously you're going to get more battery life out of it. Where we can go with this thing, our main concept was to make this a scalable concept. We knew we had to start with a minimum set of capabilities to get anybody's interest. But we like to use the example, iPhone 1 versus iPhone 11. There are going to be enhancements. There are additional sensors that can be added. One of the things that we, Phil kind of alluded to earlier, is we've just been notified that we've picked up if you're familiar with the SBIR program in the US, Small Business Innovative Research, where the federal government will fund development of certain technologies they're interested in. And we just got notified of an award to look at the best communication architecture for truly remote positioning. If you want to drop this thing deep woods or spread a number of these along a pipeline, right now we're at 900 megahertz. It works really well in an urban environment for us. But if you wanted to spread this over 100 miles, how could you do that? And so we're going to get a research grant to solve that problem. We can put additional sensors in. We've already started looking at putting a radiation sensor into the pod. And that came from our friends at New Bedford, Massachusetts, that were one of the first guys called in after the Boston Marathon bombing. And the way the story was related to us is when they went in, they assumed it was a dirty bomb, but they had no way of telling because there wasn't a Geiger counter to be had. If we can come up with a selection of pods that have maybe different kinds of sensors in them, depending upon the situation, then you'd have a mixed constellation that could be deployed. And we thought that was a better approach than trying to say, hey, here's a new chip, unscrew the pod, put this new chip in there, and now you've got X capability. It's just come up with certified rounds. Each pod can do everything. Each pod can do certain things. But you'd know what they are and could decide to deploy them based on what you thought the problems were. I think that's the IR acoustic sensors. That's something that we're starting to talk to the U.S. Air Force for search and rescue or rapid rescue. We can monitor the environmental conditions, but could we put enough additional sensors in there that could be remotely deployed that might detect human presence? So we think there are whole lots of things that we can do with this, and we're really trying to find that right direction to go. Get off the stage slide. There's our website, which is still pretty good. And then Phil actually built us a Facebook page, which is not easy for a 66-year-old guy to do.
It's 2 days I'll never get back. Let's just say that.
But it's there, and we got some other videos and interviews and silly things like that posted there. So let me stop sharing the screen for this 10 minutes. I'm sure everybody has gotten tired of me talking. We do have some videos from some of the testing we did with the drones that we can pop up there, showing the tether rig, showing the throwing the pods out the back, and I can obviously be glad to put those on if anyone's interested. But now we'd like to get either raspberries or meaningful comments about where this might fit, or even if it doesn't, that's important for us to know.
Ed, you were saying, I know when we initially discussed this product about whatever it was, maybe a month ago, you were saying that part of your expectations or your hopes with this meeting was not so much a sales pitch, but to get some ideas of how this fits in with HAZMAT and emergency response, right? You're hoping to maybe pick our brains, I guess. Is that fair to say?
Exactly. We've got a prototype system that we've been able to test fairly extensively, but it's a prototype. So as much as I would love everybody in this call to say, send me 10, I couldn't do it if I wanted to.
Right. You're hoping to try to improve the product a little bit by finding some more use cases and maybe like what we'd like to see if we could have anything in this sensor, what would it be, kind of thing, right?
Yeah, if you had a wish list that this would make it truly useful, if the concept is good, what would that be?
Ed, Mitchell Gibbs, I'm at the private HAZMAT business for quite some time. CGI would be important, and I assume obviously your PID would be the component that does your VOCs.
Actually, MOS. Very, very durable. It's very sensitive. And our goal wasn't to try to tell you, is it going to blow up, but that you've got an increasing VOC component. And then maybe you bring in the pros from Dover to truly analyze it and pull pedestrians out if they don't need to be there.
Does it have any form of LEL sensor in there, Ed, or flammability at all?
Phil, I'll let you answer that one.
It's an MOS sensor. It's actually a residential sensor that we got out of England or Europe, and it just reports 8 parts per million of a VOC. It doesn't tell you I can tell you exactly what it senses. As far as all the VOCs, it's a long laundry list of classic aldehydes and
Yeah.
But it just says there's something there. You want to know exactly what's in there? Pick up your $5,000 sensor and throw it in there, or walk it in there. But right now you can throw our pods in, literally throw them in, or have them robotically taken in. We're talking to a group of robot manufacturers that could drive into an event and drop our sensors off as they go through the area.
One thing that I think Mitch is kind of alluding to in the private sector and would definitely be of use in the public sector is flammability. That's always the number one risk for any hazmat responder. How close am I to blowing up, right? So, I mean, from a firefighting perspective, if you have a natural gas leak inside a home, to be able to chuck this inside a window and know how close it is to the LEL, how close it is to blowing up. I'm not necessarily concerned about concentration of the product or being product specific. I just want to know, how close is this to blowing up? And in the private sector, there's 1,000 use cases as well. It's not so much concentration of the product, but how close am I to that boom line? That is always like primary information for any first responder. So I would definitely be interested, or I think lots of people would be interested in seeing that particular data set. I'm not sure how you could achieve that, or if you're looking to achieve that.
Okay. It certainly gives us something to look at. Obviously that's a complicated issue. But yeah, no, that's kind of inputs that we're looking for.
Yeah, I mean, I would assume like you guys probably went with an MOS type sensor for VOCs because they're very robust sensors. They require very little maintenance, right? Not a lot of calibration, not a lot of bumping. Mm-hmm. LEL sensors, your typical cat bead sensor is pretty robust as well. So, I mean, it's obviously easy for me not being involved with the product to say, hey, it should be easy to put in there. But it would definitely be, I think, on every first responder or private sector responders wish list.
Okay.
Thank you.
I have a quick question. You guys talk about these things being priced at a point potentially that they could be consumable. Are you assuming that they would be consumed at every incident, or is there a decom procedure for chemical incidents? Is there a threshold for a firefighting incident, like temperature wise? Like how, like although they're priced to be consumable, is it expected that when they're deployed that they're lost, or how does that work?
Across the board, yes. Could they be lost? They certainly could be, depending upon where you put them in. And we're thinking $200 is probably a fair trade-off for not having put somebody in a really bad situation.
Is that your anticipated price point? $200 per unit, like per pod?
Per pod. If you put them and say you're doing your 360, or the first guy show up, do a 360 and place these in certain areas around the structure. If the event never spreads to where they are, you just pick them up, dust them off, put them back in the charging case. The sort of in between, and this is something we found at MIFRE doing the test. When we instrumented their building, we put 14 pods in. All 14 reported throughout the incident, but 2 of the 14 burned so bad there was nothing you could do with it. The other 12 had varying degrees of damage, to barely burn to significantly deformed. But the electronics were still great. So we cut the plastic off and put the electronics in a new pod. The plastic costs about $5. So it's kind of, yeah, all the above. We did design them so that we were hoping that the people using them wouldn't go, man, I'm going to get my ass in a wringer because I've just thrown this thing into a fire. On the other hand, once you pull it out and use it, if it doesn't get damaged, of course it's reusable. We've got some patents on this thing, and one of them is our recharging mechanism. We do inductive charging. The case has got the charging mechanism in it. You set the pod back in its cradle, and it starts charging all over again.
That was actually one of the questions in the chat there, how you recharge them, if they're rechargeable, kind of thing. And I guess you just answered that.
So, and
how long do they last? Like, when you deploy a pod, what's your battery life looking like?
Well, sitting in a lab, which is never a good time, they've lasted over 16 hours. Wow. In the environment where, and that was this great thing about the tall timbers thing, because they weren't going to let us hang around where the wildfire was being tested. We had to set it up and leave it, and the test ran all day for about 8 hours. And then there was a couple hours afterwards where people were still playing around. So all the sensors ran, and the control box ran for over 10 hours. And so we were able to pull 10 hours worth of data back down afterwards.
Adam was asking about the fire resistance or durability in those environments. Like, what have you experienced, like in a firefighting environment? Are they definitely tossed? Like you kind of alluded to that earlier, that some of them kind of survive, depends on proximity.
Well, in the MIFRE testing, in the rooms that we instrumented, it got up to 1,200 degrees. Now, if you can see from those pictures, part of our test was to mount the pods at different elevation, different heights off the floor, so that we could see how the temperature sensor would show the rate increase depending upon where it was placed. Since the flashover occurs at the top of the room, we knew that was going to burn the fastest and the hottest, but generally speaking, if you walk into a room, throw a pod in, it's not going to land on the ceiling. So if you put one on the floor, could you still get enough of that rate increase to see it, to say, hey, something bad's coming on? And then we pick different altitudes or elevations, so that if you had one strapped on a firefighter, might be at the 4-foot level, or maybe even up to the 6-foot level. So the pods were subjected to different temperatures, and the ones that got subjected to 1,200 burned pretty badly. The ones that were 200 to 400 to 600, the plastic started deforming, but we're using a pretty cheap plastic.
So you can replace just the shell, like if the guts are good?
Yep.
It's all 3D printed too, so we could modify the shell to whatever dimensions you'd like. And so a wearable sensor might be something flat that you could put in a pocket, or we could make it much larger and make the battery last a couple of days, or if not weeks. So,
but it'd be safe to assume with the 3D printing that it could be branded. Like if Mitch in the private sector wants to label his detectors, he could do that.
Let Ed answer that.
Well, of course. I mean, that's the neat thing with doing the. And we've even talked to people about doing injection molding, but just even with the 3D, you can do it any shape you can program, any color plastic you want. And Bill, can you hold up one of the pods that's got our logo? I mean, one way of doing it's the way that we've done it here. And this is one of the gas sensors.
Can you see that?
Yeah, so if we wanted to label that in the private sector or as a fire department, so we know that it's ours, we can do that.
Yep.
Oh, certainly.
Charles was asking about the cost. You talk about the pods being about $200 each. I'm not sure how many pods you get with a kit, but he was also asking about like the data stream, like the sending. Is there a command station? Like, how do you get the data? Is it an app? Like, what's the costing there for the whole system?
Well, our whole system, our target price, and that includes the system, the display, all the radios, software, recharging, and 8 pods around a 25K point. The pods then would be, again, you wouldn't consider the control station disposable. I guess it could be, but generally not, because that would take the incident commander out too. But then the pods at, ones we have now at $200 a pod point. Other sensors, we don't know yet. The radiation sensor is a little bit more expensive than some of the other sensors we're using. So that would be kind of a driver with those. But those would be a real special application sensor, I would think. You wouldn't necessarily put a radiation sensor pod into a chemical spill.
And that's another thing. We really don't believe you're going to deploy these for every event. It's just something you're going to have in your kit bag or in your trunk that you can use when it's like we've said a number of times, it's already fully charged, and the press of that button right there begins the data flow, and it automatically comes up in your notebook, your phone, whatever you want to do. And it also gets pumped out to whoever you want to have see the data. Again, not every event's going to require you to deploy the pods, but we think with some flexibility, the IC could make the decision to deploy the pods, even if, for example, it's in an apartment complex, and get them up in the attic of the adjoining buildings and maybe track the temperatures as they progress through the building and lead turn that problem set.
What's the, you guys talk about dropping it from drones and shooting it out of air cannons. Like, how high have you dropped it from?
Well over 500 feet.
Wow.
Yeah. Now
well,
I have
higher than you're going to fly with a drone, so that's good.
I got a lot of heat for this, but I shot it straight up in the air with the air cannon, and it landed on an asphalt parking lot. So naturally the shell shattered, but it still continued to report. We're looking into various other substrates. I like the idea of a ceramic shell that might withstand the heat better, but we're going to explore that down the road a piece. I'm absolutely shocked at how rugged these things are. The chips themselves can withstand all kinds of G-loading and extreme temperatures. I took it out of a burned building at 400 degrees and I put it into a CO2 extinguisher. And oh, look, Ed wants to show you the drone toy. We got to play with this for a while. We actually had a certified drone pilot. And this was a farm out in New Bern that allowed us to come out and play, if you will. We experimented with, I think this one's the tether system.
No,
Bottom line is the whole
sensor.
concept of the tether system really resonated with our, this is the data stream coming off the hardened laptop that we bought because we think we needed that. But the New Bedford HAZMAT kid said, if you can let me tether and sniff, for example, a deserted boat, I'll know what's in there and I'll have a better understanding of how I can attack this. That's the plane he flew. He has to show that to you.
Of course.
Yeah, I understand. I never got to go faster than sound.
But I'm calling up something else here real quick.
The shocking thing about these drones is how easy they are to operate. I've been frustrated with, everybody should have one because it gives you an immediate bird's eye view of the situation. This is the tethered rig where it's coming off a reel that we could control down and up, and it's on a metal cable, so it's not going to burn off. I'm not going to say the UAVs are consumable because this is a little toy that I don't remember what we paid for it, maybe $1,200, but it gave us an understanding of the effect of how to use a drone in an environment into an event. Again, there's an F4 going supersonic. Not sure what this was. Oh, we had a deployable, we had a tube that allowed us to select.
No, this is the tether. Tim, this is the tether.
Oh, good. You can see the pod floating around. We assume that rusted hulk is the HAZMAT event. And so this is the view from the drone as it drops the tether, drops the pod into the event. And you can imagine it sniffing the area to see what's going on over there. Again, a good item might be radiation, might be just high temperature, or VOCs. So it gives you an understanding, and you're 500 feet away at least. The 900 megahertz has a great range. At the time, we were using Bluetooth, but we still got good ranges from the Bluetooth. And like we said, this SBIR will give us the ability to determine the best comm architecture for the event. In other words, it may be 900 megahertz and it may be satellite. That's an overweight Phil Tinsley shooting his air cannon. I've since lost some weight, but I haven't gained any bigger. If you can see downrange, we're shooting at least 200 yards, and we're getting reports the entire time. It was a lot of fun. And I have also been told by most fire chiefs, do not send me an air gun. My men will kill each other with it. So it's, and then once that it's a win, Christmas time, you can start shooting candy at kids from the truck. Any questions?
I apologize, my internet cut out. What's the overall price again?
About $25K for a full system.
Another thing we haven't talked about is I think there's a role in training. Denver chief said, I need to understand exactly what all my men and women have been exposed to through the course of their career, so that maybe we can understand that what's causing these cancers in you guys at a very young age. That's another doable where we would assign a pod to an individual and be able to pull down. Now, I'd love to have a more robust sensor as to identify exactly what they're being exposed to, hydrogen sulfide, hydrogen cyanide, whatever the case may be. And that's another, iPhone 3 or 4. But right now, the understanding that as you go into a training event, we can pull them back and say, okay, that was 500 degrees. You went too deep into the event and your gear starts to melt off. So I think it'd be an interesting, we've talked or discussed the idea of using training as a service, where myself and some of the other gentlemen show up at these training facilities and instrument the students, if you will, so that they understand exactly what their environment and what they're encountering.
Safe to assume it's water/weatherproof.
Yep. Yeah, I've got an O-ring on these, and we do have the Venti logo going through. That doesn't have to be the case. Just like you said, if I can have the my logo put in there, we don't have to go all the way through. We do have to go through if we're going to use it as a volatile compound sensor. In other words, I've got to get the gases through there. But if we're not going to use it as that, if we're going to simply use it as a sensor for the environment, then we can seal it. Again, that becomes a color-coded pod in your display as to what you want to deploy and how you need to deploy it.
And one thing I guess I'd like to add, I think hopefully I implied it, but let me state it, that the architecture design on this is so that once someone has the system, as new sensor pods come available, they don't have to buy a new system. New sensor pods will just slip into the constellation.
Awesome. That was awesome, guys. I really appreciate your time. I'm not sure if anyone else has any more questions, but I think it's a very innovative product, and I think it has a lot of potential for sure.
One last question. Do you have sensors? Like I can see this being really good for the police officers that are on our OMRA team, your Burnsides and those guys that can that be used for all your real nasties, your nerve agents and your
chemical warfare type stuff?
Chemical warfare.
Yeah, we don't sense nerve gas, things like that at this point. Now, is that something that we're talking to the U.S. Air Force about? Yes, but that would be something down the road. But the concept is the same. Instead of having to set somebody in there in MOP level 4, and then hopefully doesn't get contaminated, you throw these things down, and then at that point in time, you don't even try to decontaminate them afterwards. They're collected and disposed of. we did get an interesting conversation. I know we're almost out of time here. There's a police leadership course or curriculum at Johns Hopkins University. And we got to talk to the director who's running that thing. And he was very concerned, not so much about SWAT team law enforcement, because they're pretty well equipped, but your standard patrol officer who may or may not be by themselves when they show up someplace and walks in with nothing other than his eyeballs and maybe a radio. In fact, they call them blue canaries. If they come back out, then everything's okay. Be able to use something like this, because in a lot of cases they're the first people on scene before a fire crew or hazmat crew can show up. So he was interested in just knowing, you know, is it hot? Is there some potential for explosive activity where he's going? But if we could get to the point where we can measure some of the typical or more prevalent type nerve agents, well, then you've got military applications, a whole bunch of stuff. If you could set these things out there and just let them monitor, that all is real point, really well taken.
Thank you.
Awesome. Well, thanks again, guys. I'm not sure if there's any more questions, but again, I think it's a great product, to be honest. I think it's got a ton of applications. So,
Well, and if anybody has got the time to talk to us further, we would be greatly indebted.
perfect. So you put your contact information there, and if anyone doesn't have it, I can obviously connect you guys as well. So thanks again for your time, guys. I really, really appreciate it.
We get to go to another one of these right now.
Yeah, so do I actually. So perfect. All right, good luck, guys.
Thanks so much.
Thank
Bye-bye,
you so
guys.
Thank you very much.
Bye, all.
Be safe.